Okay, this is mock exam 2. It looks like the solutions are a little bit out of order. Most of them are there, but some of them maybe not. But anyway, I'm going to go through all of the solutions in the multiple choice in this video. So we've got this first one, a sine graph. We've got amplitude, we've got a downshift. So it's fairly easy to see that that's going to be contained between 1 and -5. So we only have to worry about the period, which is 2 pi divided by your n value of 3. And so we get the correct answer of A. Moving on to question 2. Pretty straightforward function if you just sketch the graph. We're looking for that end point that matches up with our y value of -4. So we replace y with -4 and we get x equals 9. Okay, so polynomial P3 equals 10. We're using the remainder theorem. We just substitute in 3 and we should get 10. Solve for that and we get A equals 1, which is answer C. Question number 4. Got a log law. So we can get out of that log law by saying that it's a to the power of y minus 3, work our way through the algebra, and we get answer C again. Question number 5, inverse functions. So we have to swap the x and the y. We also have to swap domain and range. So subtract 3 from both sides, then invert both sides, square both sides, and swap the domain with the range. And so the correct answer is D. Question 6. Oops, ignore that first line, that's a bit of a mess. So what we need to do is, in the second line there, we replace x with function x in g of x. So that green bit is function x, replacing the x in gx. When we do log base e of e to the 3x, that just simplifies to 3x, and we get to our answer D. Question 7. Turn your page so that the line y equals x is a vertical line, and then it's easy to draw a symmetrical graph. Don't forget the key points. So the intercept 2 on the y-axis now becomes an intercept 2 on the x-axis. The asymptote at 3, the original function, so y equals 3, now becomes x equals 3. So that's going to be that graph down the bottom there, part E. Alright, we've got a quadratic getting 2 real solutions. So it's b squared minus 4ac. That has to be bigger than 0 to get 2 solutions. You can do that by using solve on your CAS and just type it in. Question 9. We've got function x, we've got function g, and we want the maximal domain of the function x plus g. Okay, so for function x, that only exists where x is greater than 1. Function g only exists, where x is less than 1. Function g only exists where it's greater than or equal to -1. And so for the combined function to exist, both of those conditions have to be met. In other words, A. Question number 10. You can use proper fraction, or you can use long division or synthetic division to convert that into a form that you could sketch if you like. Or -1 take away 1 over x minus 2, and so then it's pretty easy to read off where the asymptotes would be. It is D. Question 11. Midpoint formula, x1 plus x2 on 2, just the average of the 2 x values and the average of the 2 y values, we get A. Question 12. So this is a tan graph kind of a shape, but you'll notice that the period is only pi on 2 instead of pi. So we know it's a dilation factor of 2 to get that to be halved. We also know that it's got some kind of a shift to the right or to the left. So you can go through a more complicated version of all of that and look at a kind of a general solution to it. But realistically, there's only 2 answers with the correct period, C or D. One of them is a right shift of pi on 4, and one of them is a right shift of pi on 2, and it's the pi on 4 that we want, so the answer is C. Question 13. Probably the easiest way is to just do it on a graph. You've got your graph down here, it shifts up 4 and then reflects across. It's negative 4, 1. I think the solutions have a more complicated version of that. But don't forget, there are often easy ways to do them. Right, this next function, we've got either a whole or an asymptote at x equals 1. Straight away you can see that that's the first one, A. Don't really have to take it any further than that. Question 15. You can just define your function x equals x minus 2, and then you just type in those equations exactly as they appear, and they should say true all except 1. Question 16. We have got a series of transformations. Up 1, reflect across the x-axis. Got a dilation by factor 3 from the x-axis. A left pi on 2 and a dilation by factor of half. The only one that matches that when we look at our notes on transformations is D. Question 17. We've got a dilation and we've got a reflection. So it's squeezed inwards and then it's flipped upside down. Correct answer is E. Question 18. To get a gradient between 2 points, we use y2 minus y1 over x2 minus x1, back to year 9. And then to find the perpendicular one, we need to invert that and swap its sign. So it becomes positive half, it's A. Question 19. So we've got a graph obtained from Gx by going through a reflection and then a dilation. So the reflection makes a new function, if you like, hx, which is negative multiplying gx. And then to dilate it, we replace x with 2x. That would be a dilation by factor half. And so the correct answer is D. Question 20. So I'm simply multiplying my main 2 across here, m times m, and then subtracting 12 times 3. So it's m squared minus 36 equals 0. If it equals 0, then that will be either infinite solutions or parallel lines, no solutions. So everywhere else is a unique solution. So solving that, I get m equals positive 6 or negative 6. All other values give a unique solution, and so the answer is C. 21. It's a tan graph. So the normal period is pi. We divide that by n. N in this case is 2 pi. That comes out to be half C. Question 22. Hopefully you spotted that you could write e to the 4x as e to the 2x squared. Now it becomes a quadratic. We solve the quadratic and then replace u with our e to the 2x again, solve for x. Correct answer is E. 23. similar one again where we have to replace this time e to the x with u, get a quadratic, solve it, and then find our two solutions for x. 24. In 24 we've got this function here. Best to write it in the form where you can read off translations and dilations correctly. Correct answer is B. 25. So, don't forget, whenever you're doing a function, you always want to find the range of the original function, because that's going to become the domain of your inverse function. So, we replace x with y and y with x, solve that. Correct answer is D. Next question, we've got a graph, it could be sine or cos. Its period is going to be pi over 7. That immediately narrows it down to A or B. And then you've got an amplitude 5, up translation 5. We've just got to decide whether it's sine or cos, whether it's positive or negative. So it comes down to, since A and B are both cos anyway, B is the correct answer. Question 27, easier than you might think. So we've got a cubic graph, this S-bend shape. The only way you're going to get one solution, in other words, for that equation of equals 0, we're talking about an x-intercept. The only way you get one x-intercept is if that S part of it is either shifted above the x-axis or below the x-axis. So in other words, the solution is going to be W has to, because W is the upshift on the graph, so W is going to have to be bigger than some value, or it's going to have to be smaller than some value. So the only one that really matches that look is answer D, so we don't really have to solve that. Question 28. I'm just figuring out if I've got my function x, what function 2x is and what 2 times function x is, until I get a match, which is C. Question 29. Factor theorem. So P minus A has to equal 0. Substitute minus A in, and I stuffed that up. So I'll quickly put that bit there to finish it off. So that simplifies down to A is equal to 0 or negative 3, but in the original question it was A had to be any real value except for 0, so that means that only B is to be considered. Alright, question 30. We've got intersection of the graph at 2 distinct points. So that means that when we let one equation equal the other, we have to get 2 solutions. And when we're looking for numbers of solutions, again, it's b squared minus 4ac. So just do that on your CAS calculator. Solves it to get B. Question 31. We've got the range of this function. So I'll draw a quick sketch of it there. You can of course just plug it into your CAS calculator and it'll sketch it for you. You've got -6 as the lowest point in the range, and the highest point is that maximal value at the turning point, which is -2. So the correct answer is C. And the last question, question 32. No real roots. So again, we're looking at b squared minus 4ac. So it's a quadratic. The coefficient of x squared is p minus 1. Coefficient of x is 4. Coefficient, or the c value, is p minus 5. Plug that into the equation and then just solve on your CAS calculator. You get the correct answer of B.